Hello. For those of you that were here and suffered through my last talk, I'm sorry. This is me ranting again for another 60 minutes. This time, however, this is a genuine war story. And what I want to do is I want to take you through a real incident that happened to us. It's about 14 months ago now. I was just telling the people on the front, I did this session for the first time at KCDC in August, and it was kind of weird because I was standing on the stage exactly 1 year to the day since everything went wrong. And what I want to talk about is what happened to us, how we handled it, importantly, how we worked together as a team, how we stood up a conference bridge, how we delved through our telemetry, how we figured out what was going on, how we took out contracts on several people in several project teams, that kind of thing. For those of you who don't know me, my name is Rik Hepworth, conference speaker by day, Azure consultant by night. And I work for a company in the UK called Azure, which is part of the Azure International Group, founded by Finns, who are wonderful people. And I've been at Azure now for almost a year. So, my life as a consultant is one of those where it's really, really peaceful and punctuated by moments of intense panic as people message me. And they usually issue those fateful words, "Hey, Rick, is something wrong with insert application here?" You've all had it, right? And the obvious response is, "I don't know. Is there?" Sorry, I'm losing my voice, which is just great when I'm speaking through a session. So I'm having a really peaceful day. My customer is in the States, which basically means I get up at 9 o'clock and I have a really nice, easy day as I'm doing deployments and doing infrastructure as code and basically doing real work. And then they wake up about 3 o'clock in the morning and the rest of my day is just meetings, because that's the way it works. And I get this message in Slack, which feels pretty simple, right? Hey, I've just run our pipeline because we're really organized. So, whenever we do commits, we trigger a CI build. The CI build triggers a deployment into our dev environment. Everything's automated. And it failed. And my colleague said, well, I can see where it's failed. So what we do in this application, we have an API, which is hosted in Azure Websites. And that API is then dropping messages onto Service Bus. We're using the End Service Bus framework, this sort of message-driven application. And those messages are picked up by Azure Container Apps that do the work, if you like, and they're talking to an Azure SQL database, and they're calling external APIs. And our APIs are fronted up by API management. So what we do, as part of our deployment, we deploy the updated API to our website, .NET API. We then do a slot swap, which warms the API. And then our infrastructure as code reaches out to load the Swagger JSON from the website, and it loads that into API management to create the managed API in APIM. And that was failing. And it's like, okay, well, that's kind of interesting. So I had a look, and I looked in App Insights. So we're using Open Telemetry. It's all .NET Core, .NET 8. Every single service is configured to emit diagnostics and audit into log analytics. And every single piece of code we've got, whether it's running on our website or in our container apps, is instrumented with Open Telemetry and the App Insights SDK, and it's pouring all of that telemetry into our App Insights workspace. So if there's an exception, I can go to App Insights, and I can look at what the exception is, and I can see what's going on. So I get this message, I go to App Insights, I look at the exception, no exception. More importantly, no telemetry at all. Okay, that's a bit odd. So I went and had a look at Kudu. Is everybody here familiar with Kudu? A few people. So for those of you who aren't familiar with Kudu, it's brilliant. I'm going to skip ahead. So the way I've formatted this presentation, we have an incident log, and I'm just going to put up items from the incident log. So this one I did in retrospect. My colleague said, hey, it's broken. And I went, yeah, no, it's not. Let's have a look. And I looked in App Insights and there was nothing. How many of you instrument your code using some kind of telemetry provider? That's a shockingly poor show of hands. Right. All of you that didn't raise your hand need to go and look up how to instrument your code using some kind of telemetry provider. I'm pretty sure there are sessions on App Insights and Open Telemetry at this very conference. Trust me, it will save your ass so many times. But in this situation, I couldn't find it. So I had to look to Kudu. And Kudu is a really, really old, been there since the dawn of time with Azure App Services service. If you go into the App Services website, you can find advanced tools, the little blue Swiss Army knife. And that will connect you to a site which is your website.scm.azurewebsites.net. Now, what that lets you do is it lets you spelunk around the website that's running, your app service instance, your hosting plan. So I can look around in PowerShell, and I can find the logs. Now, this is running on a Windows hosting plan, which means I have two files there, that event log prev XML and event log XML. Everybody familiar with the event viewer on Windows? And you go look there if you get issues? Right. Event log XML is the raw event log for that app services. So I went and I opened up that event log. And what I found, which we registered in our incident log sometime later after I'd stopped panicking, was that I was seeing exceptions, and the exceptions were happening pretty much on app startup. It wasn't getting far enough to generate the swagger. And I'd seen this before, because the very, very first thing our application does before anything else is it goes and gets its configuration. Now, when I say goes and gets its configuration, we have code and we're using the app config SDK. So we use the application configuration, app config service in Azure. And that's pretty cool. I can go and put a request out and it'll give me a formatted JSON structure with key value pairs for my app config. Now, one of the things that you can do with app config is you can front up KeyVault secrets. And the nature of our application means we've actually got quite a lot of secrets, about 50. And what happens is the app config SDK reads that block of JSON, and some of those config items are links off to KeyVault. So it then gets the KeyVault secret URL and goes and calls KeyVault. And because I've got all of my telemetry, even though I couldn't see the exception in App Insights, now I've got this failure and I can see an exception as it's trying to stand up and get its configuration. So I went and looked at KeyVault, which looked like that. That point there was a few hours earlier than when I got contacted. Over here is normal running, calling our KeyVault. Every now and again we get a bit of config, it's all right, so I need a setting, I can do this whenever I like. And all of a sudden, what the budget? And it was sort of over here-ish when we finally noticed. Now, there's a moral in that one. I'll call these out as I hit them. We'd got beautiful telemetry, but we didn't have alerts on some of our services. So our KeyVault went crazy, but I didn't have any alerts that said, hey, if the volume of KeyVault traffic goes above this normal level, page me, scream. I don't care what you do, tell me something's wrong. So one of the learnings from today is telemetry is fine, but if you're not actually looking at it actively, if you're not actioning it, if you're not creating alerts that tell you if something's wrong, what good is the telemetry other than something that you can go and hunt through later? Having said that, there's value in that, as we shall come to through the story. So, at this point, past me is like, oh God, hang on a minute. This is our dev key vault. In fact, actually, no, I think that's our prod key vault. So Rik says, hang on a minute, our dev key vault's broken. Let's just double check all the other environments. And we've got 4 environments, 5 environments. Every single key vault was basically being DDoS'd. It was just sat there at well over, it was peak utilization, and it was just issuing back 429, please come back later. Every single key vault. So then Rik's like, hang on a minute, that means production's down. Crap. Fortunately, it wasn't. I'll come on to that one in a little bit. But at this point, there's enough of a panic that I said, all right, we need to look at this. So we stood up a conference bridge. Second learning from this one. If you are the person that sees something wrong and you get to the point where you're not sure what to do next, that's the point where you call your teammates. And the best thing you as a team can have is some kind of action plan, right? That says, what happens? What happens if everything's hitting the fan? What happens if stuff is going on that we don't know what it is? What do we do? And it's really important if what's going on is potentially impacting production, right? And what you should do is have an incident plan. Did the organization I was with have an incident plan? Well, as it turned out, we discovered after the fact, yes, they did. Had they shared that incident plan with the application development team? No, they hadn't. Fortunately, I'd been in that situation before, so I said, right, we are going to stand up a conference bridge, and we are going to have the senior people from the dev team, and we're going to pull in some certain people from the senior, the management, right, the owners of the application, and we're going to articulate what the problem is, and we are going to work through this. And the first thing you should do when you have an incident is you should start writing things down. Because then, 12 months after, you can make a really cool conference presentation where you use the incident log and you can go, hey, look at all the things we did. No, wait, hang on. Seriously, though, if you don't write things down, how do you know what you did or didn't do? And if you don't know what you did or didn't do, how do you learn to not do the things that didn't work and to do the things that did work? How do you know when you need to look through the incident and figure out what you did well and what you did badly, and actually write that proper incident plan for the next time all of this goes wrong? So we stand up a Teams call, and I start looking slightly further afield. So my first working theory, because of when we spotted the error in our pipeline, I was thinking, well, is this something to do with our app services? Have we triggered something? Have we somehow, because we've done a deployment, we've made too many calls to KeyVault, and that somehow pushed it over the edge, and we can't recover, and everything now is making calls to KeyVault. So I went and had a look at the Azure service status page. If you have a problem in Azure, the service status page is one of the first places you should look. Because if there is something going on in Azure itself that is going to impact you, that service page will be updated. It might not be updated immediately, but they are pretty good at updating that and saying, I don't know, EastUS 2 is on fire, your app services isn't working. Now, when I looked at that, there was a little notification. And that notification said, that there was an advisory that might be affecting app services in EastUS 2 because they were doing engineering work and they were doing a rolling upgrade. And I thought, oh, that's interesting. Maybe, if you remember that graph from earlier, maybe at silly o'clock in the morning, the app services team had done something to my app services environment, and that's what triggered it. So fortunately, I have friends on the app services team. So I did what every MVP does, which is basically get on Teams and go, oi, can I ask you a question? Have you guys broken anything? And I laid out what I was seeing, laid out that I'd seen the maintenance announcement, and asked the question, has anything gone wrong? Is this something that might have triggered my issue? And my friend, the app services PM, responded. Now, just because you don't know the app services PM doesn't mean you can't ask Microsoft, right? So the other thing that you have to learn is, at what point in an incident should you log a support ticket? And in my experience, my answer to that is, as soon as you have something you feel is actionable, because the support process can take a while to get into gear. So, my KeyVault is going crazy, my app services are going weird, maybe not quite, but as soon as we've got something we think is actionable, we'd log a service ticket. So we probably should have logged a service ticket at this point. We didn't, which is a learning. Now, my friend said, well, why don't you have a look at the audit and diagnostics coming out of the website? Have you turned diagnostics on? Have you got that coming into a log analytic workspace? And I went, yes. So we had a look. Now, that point in time where those curves cross, as it turns out, was exactly the same point in time that our curve went wee on the KeyVault stuff. What that graph is showing you, the blue line is requests being serviced by one instance of app services, and the black line is requests being serviced by another one. And effectively, that's showing you the instance swapping, which Azure will do periodically, and it will try and do it safely for you. It'll recycle, it'll sort of shut down all of the requests on one and bring up another one. And it might be because they're doing maintenance. There could be all kinds of different reasons. And it's at this point that Rik falls into the correlation is not causation, ha-ha trap. And he looks at that and goes, well, crikey, that looks like what triggered it, right? So app services has had something, it's rolled our instances, we request configuration information on each of those. And the interesting nuance is, at this point, so we have 14 web APIs, each of which has a production and staging slot. And because of decisions that we're taking early on that we hadn't done anything about, all of those instances ran on the same app hosting plan. So recycling the hosting plan caused 28 websites to suddenly try and retrieve their configuration, each of which is 50 secrets. So you can see my line of reasoning with this one, right? That, all of a sudden it's fallen over. What I should have realized was that's only one set of app services, and not all of the other app services looked like that by the time I dug in. And I think that's the other thing you've got to learn here. Sure, form a hypothesis, but don't assume you've suddenly found the truth. What you've found is a possibility. And what you should then do is say, can we find evidence to support that and prove or disprove it? And I fell into a trap there that I didn't do that. So, my friend, the app services PM, talked to his engineering team and came back to me and said, look, Rik, it really wasn't us, all right? No matter what you think, we're not doing any engineering work in EastUS 2. We haven't started yet. So we didn't cause the cascade. We didn't start the fire. It isn't us. You can't pin that on me. Okay, fine. What else happened? Well, then somebody said, oh, hang on, the networks team made some config changes about that time. I bet it was that. At this point, I went, well, hang on, what config changes did they make? because config changes to on-prem networking is unlikely to affect the cloud, right? So again, ask the right questions. That one we fairly swiftly got rid of. And then somebody said, what about our code? And we went, that's a fair point. Because no matter what triggered it, our code is the thing that is calling app config, right? And our code is the thing that isn't backing off and is continuing to batter things. How often do we call app config? What are we doing? So we started to dig, and we found a bunch of interesting things. So we were using the app config SDK. There's a documented, suggested way of using that, where you make a request to a thing called a sentinel key, which is a specific JSON key value pair that you only change when you update something in the configuration and you want things to reload. So we're polling this key. Now the default in the app config SDK is it polls that about every 30 seconds. My team were really concerned that we might have to push out a configuration change that was really, really urgent. We had to update it now. So they changed that. So on a timer, we checked the config every 10 seconds. Okay. Now, if you call KeyVault and it hands back a 429, on that request, it waits 40 seconds before it gives you the 429, because it's trying really hard to make you leave it alone because it wants a quiet life. So our minimum time to retrieve config would be 40 seconds at this point. It was actually more because we'd got lots and lots of secrets being retrieved in sequence, but let's say 40 seconds. The problem was, whoever wrote the timer didn't bother to check if there was already a request in progress before starting a new request. So we asked for configuration, waited 10 seconds, we hadn't got it, we fired off another request. By the time the response to the first one came back, we'd already fired off another 4. Right, okay, so now we found a problem in the code. So it's like, okay, well, can we see where these things are coming from? Can we start to trim down the things that are calling stuff? Because you know, we're running in production. Are we trying to identify services that we can shut down? So the first thing we did, we started writing some cool KQL queries. KQL is a bit like crack. You know, the first time you do it, you're just going, I want to show everything in requests. And then you start to find all the really cool statistical things you can do. And then you wake up 3 days later in a dumpster. So I warn you about that one, but it's incredibly powerful and really helpful. So what this graph shows is it's looking at the requests to KeyVault, and it's parsing that request to find the identity that was passed in when we call KeyVault, because we're using managed identity and service principals and things. So each little block, each different color in that bar chart is a different service. And as you can see, we've got 2 colors there that are accounting for quite a significant proportion of the calls. And all of the ones up the top of the bars, they were all managed service identities, right? So system calls from our container apps. But these 2 were people. At which point you go, hang on a minute, have we got developers talking to our KeyVaults in different environments and just battering them because they run multiple containers on their KeyVaults? So we said, can you turn them off, please? Don't turn them on again. And that's another thing to take away, right? If you've got an incident, particularly if that incident is affecting environments that development and your sort of normal processes are interacting with, you should stop your development and those normal processes because you want to get all of that noise out of the way. I realize that means the devs are probably sat drinking coffee and you really want them to be cutting code, but it's very difficult to start isolating the root cause of a problem if people keep playing and firing up debug environments and that kind of stuff. So we shut the things down, and it didn't make a blind bit of difference. So the team then said, okay, well, look, why don't we identify all of the non-essential services, and let's see if turning stuff off cuts that load down. And let's try some experiments. What if we turn everything off in dev and then turn it back on again, but stage it? Can we start things in a way that we don't get this cascading failure? So we did things like that. And you can see we've got everything basically turned off around here. There's only a few things issuing requests. We turned it all back on again, and we got a gazillion requests. So just stopping it and starting it didn't help. So what we ended up having to do was basically just shut down services. And we basically got to a point on day one where we had shut off as much as we could in non-production environments because we wanted to just get those out of the way. And we turned off everything that wasn't essential in the production environment, which fortunately we were able to do. And we were lucky, we'd only just gone live. Of all of our APIs, of all of our services, we'd only got a couple or three that were actively being touched by customers. So we could turn off like 75, 80% of the system. And that managed to drag it down just enough that we weren't triggering so many 429s. At which point we went, do you know what? It is really late. Let's stop and go to bed. All of the times in here, by the way, are UTC. That's personal preference. When I'm doing an incident log, I like to do UTC because I'm used to working with teams from around the world, and doing it all on Zulu time just makes a lot more sense. And because the default clocks in Azure are all on UTC, so it really makes it a lot easier when you're looking through telemetry. So we come to day 2. And I am in the UK. My colleagues are in the US, so which means I get on nice and early, and I start to look at what's going on. And the answer was, well, it's still bad. It's better than it was. I couldn't find any way to increase the KeyVault capacity. That's a fixed thing. I couldn't find at the time what it was that had triggered the change. And then I had a bit of an epiphany. And I thought, well, hang on a minute. We've assumed this is KeyVault. Again, we're making an assumption, right? The evidence is showing us that KeyVault is broken. Is that actually cause or effect? And now I've actually had a chance to sleep on it, and I'm the first guy up, and nobody's on the bridge with me. I realized that, hang on a minute, we call app config, and then we call KeyVault. We never looked at app config yesterday because we were so busy firefighting and trying to bring things back into line and get rid of the effects that we didn't really bother to deeply go through the symptoms. So I looked at app config. Now, has anybody dug into what happens when you call application config and you use the Sentinel key and all that kind of stuff? Probably not, right? Because you trust the SDKs, you trust the services. So when you choose to use a Sentinel key, the app config SDK makes a very specific call to get the value of that one key. And the app config service responds. And if the key value hasn't changed, it responds with a 304, unchanged. If it has changed, it responds with a 200. The app config SDK, when it receives a 200, goes and gets all of the config from app config, which means it then sees all of the secrets and goes and gets all of the secrets from KeyVault. Once I'd learned that, because I read the documentation, that's a graph of the app config responses. Red line is 304s. Blue line is 200. The point that they cross is when our KeyVault decided to commit Harry Carry. That should not happen, just to be clear. At which point now I've got to, hang on a minute. This actually does feel like it might have been the trigger, right? Something has happened to the app config service outside of our control, and that makes sense because all 4 of our environments were affected, and when I looked at the telemetry, all 4 of our environments were affected exactly the same time, and I could draw the graphs on all of the telemetry for all of the environments, and the graphs all looked exactly the same. 304 switches to 200. At which point, I found a smoking gun. Now, again, at this point, you should log a support ticket. I did what I can do as an MVP, which is I mailed the product group and went, hey, app config product group, this is what I'm seeing, this is when it started, this is all the telemetry, have you made some changes? And then time went by. And then a few other people on the mailing list that I know said, oh, yeah, we spotted this, Rik. It looks like it's a big one. We're chasing the product team for you. So time is ticking. The app config team should be looking at this. Meanwhile, now we're a bit stymied because there's nothing we can do ultimately to fix this other than can we make config changes in our code? Can we change our behavior to try and lessen the impact? So just to show you, this is like graphs of how many calls to app config we're getting, which again, you can see just shoot up when they change their response type. And calls to KeyVault across all of environments that just explode. So our team are making changes to our code, which we're rolling out, and they've done a few things at this point. So they've increased the default timeout from 10 seconds to 5 minutes, but they've made it configurable. And they've made it configurable that we can turn it off, which is important. If you haven't already implemented circuit breakers on the services that you call, you should. Because you never know when you're going to DDoS yourselves, and it's a really good pattern to follow. You need to think defensively, what's the worst that can happen? If our applications are running, which they were, and they can't get changes in configuration, what's the worst that can happen? What's the risk of that? Versus if we can turn this behavior off and we no longer have, KeyVault 429 and all that kind of stuff, surely that's a better bet. So we started making changes. Meanwhile, as we're rolling out updates, which are, because we've got CI/CD, right? So these things are going through each of our environments. We're checking what's happening in the lower environments, proving that we are making a difference. And only if we make a difference do we advance to the next environment and finally onto prod. Meanwhile, the app config team are looking. And the app config team mailed me back and said, thanks for getting in touch, Rik. Just to let you know, we're investigating the incident. This was about 5 hours after my original email. 10 minutes after that email arrived, everything started to behave itself. And a couple of hours after that, I got an email from the app config team saying, hey, Rik, we found the fault and we're rolling out the fix, which is basically we're doing a service update. Brilliant. So as we start day 3, I wake up and I'm a happy bunny, right? Because now I'm looking at telemetry and things have settled down. But now we have to do the hard part. So, the devs are really happy that, hey, this is fantastic. It's all gone away. It's working again. And somebody said the very important problem was, I'd really like to know what actually happened. What is the root cause of this? So, we closed our bridge, we confirmed that we closed the call, and then we started doing some digging. And I'll come on to the digging in a second. But as you can see, at the point they issued the fix, all of a sudden our app config went from issuing 200s to issuing 304s. And our KeyVault volume dropped off a cliff. Brilliant. And then we started to look at what had actually happened and what the impact was. And one of the biggest impacts was there's always a cost, right? So we had basically DDoS'd our KeyVault for 24-ish hours. And in one, this is just prod, it cost us nigh on $1,000. Now, you can argue that that's small beans, right? But if you're a small organization and it's just cost you $1,000, that's a significant hit potentially, you know? So there's a bunch of things I want to talk about. And before I show the final slide, let me tell you a story about the app config SDK. So I'm really fortunate to work with some very smart people. And one of our team, he's a former .NET MVP, and he said, you know what? I'm going to go and have a look at the app config SDK and see what it's actually doing. And he worked his way all the way through the code, and he found the bit of the app config SDK that calls KeyVault, and discovered that the app config SDK is built on the KeyVault SDK, which makes sense, right? So then he went and looked at the KeyVault SDK. When KeyVault responds with a 429, the KeyVault SDK raises a very, very specific type of exception. What do you think the app config SDK did when it saw and received that very, very specific type of exception? It retried. Yes. It didn't think about it, it didn't pause, it just went, oh, there's been an error. Let's have another go. So, my senior dev wrote a 2-page report on this with all of the, the points in the code where it was a problem and what was going on and evidence and the whole lot, and we provided that to the app config team. And that's one of the things that I want to take away with this one. Yes, the app config team caused me to DDoS my KeyVault. Did they do it deliberately or maliciously? No, because for the most part, the human beings that work creating the services and the libraries that we all use are not malicious. And they're not incompetent either, but accidents happen. Part of me does want to say, well, if this is such a fundamental part of your service, how do you not have a unit test for what type of response you hand back? But, I know that the app config team themselves took what we'd reported and they did their own investigation because they needed to do an RCA in the same way as we did an RCA. So the first thing is this. If you don't have telemetry, and I mean telemetry, not logging, right? Logging is what a dev did with their holidays. I am now entering the subroutine that goes and paints this gerbil pink. I'm now exiting the subroutine and the gerbil is pink. I don't care. How much memory was it using? How long did the call take? How many calls are we getting? What exceptions are we getting? All of that kind of stuff telemetry can tell us. And what you also must do is not just think about your application. Azure runs PaaS services that emit their own telemetry, and you should pour all of that telemetry into a log analytics workspace, and that should be the same log analytics workspace that your App Insights telemetry is going into, because then you can execute queries that join the two together. And that's really important if you want to try and figure out what's going on like we did. The next thing you need to remember is you need to take a decision early on as to whether this is a business impacting situation that demands some kind of managed process to handle. Now, that doesn't always mean it's production affecting. We might have been safe that our production environment was fine, but actually if it was affecting all of our lower environments to the extent that it was, we probably would have stood up a bridge anyway, because there's always a risk that prod is going to be impacted. You should always keep that log of events, and they shouldn't just start when the incident log, when you stand up the call, right? You've got to reach backwards in time. So our report, our incident log, actually started at the point that we realized the original switchover had happened, when app config went rogue. That was the first event, and everything happened after that. We didn't notice for several hours. And that's important. And if you don't look back and find when things actually started happening, you don't necessarily realize, well, we missed it. Why did we miss it? And you missed the learnings. What you shouldn't do, though, is drag everybody into the call and keep them there. It doesn't matter if nobody is on the call, providing you know what you're doing and you've issued tasks and you've set a deadline to come back and report. One of the best approaches, I've had different incident, but it involved a couple of teams. And what we effectively did was we ran it as mini sprints. And every 60 minutes, it's like, right, here is the work we're going to do in the next 60 minutes. You're going to go look at that. You're going to go change that. You're going to go update that. You're going to deploy that. And you're going to come back in 60 minutes and tell us, how far have you got? What are you stuck on? What's working? What's changed? How are we doing? Don't demand that people set on a call, because if your senior developers are on a call, then they're not being senior developers and doing what they're good at, right? Which is the investigative work and trying to work out what's going on. So as management, you have to realize that you need to delegate and get people to report back. And as managers who are running the incident, you need to be aware of who you need to report up to. So we were keeping the exec vice president who owned our application informed about what the potential business impact was, because they might need to talk to our customers. They might need to issue messaging. They might need to turn services off and say, you know what, Mr. Customer, we're actually going to turn everything off for 20 minutes, which has a real impact. The one mistake that, as you can see, I repeatedly made, don't jump to conclusions. It's really easy to do. It really is, But correlation is not causation. Just because you can get the lines on the graph to line up doesn't mean they're related. And I've learned that one the hard way. And the best approach for that one is you have more than one person on the call and you challenge each other. Show me that, Rik. Prove that to me, Rik. Rubber ducky, tell me how you got from that evidence to that conclusion, and challenge it. Because if the hypothesis doesn't stand up to scrutiny, then you know what? It's probably not right, and you need to move on and do something else. You then must, at the end of the incident, write it up. What happened? When did it happen? What did you do? What was the effect? What was the resolution to the incident? And the resolution, of course, may not be that you actually resolved the root cause. You may have just put a mitigation in. And an incident report is really not that useful unless you call out actions and learnings. We learned that we were making calls to app config every 10 seconds, and as it turns out, that was insane. Yes, we'd got a bug in how we were doing it, but the actual act of doing it was also crazy. When we then sat down and went, do we really need to know within 10 seconds? The business went, no. 10 minutes is probably fine, and frankly, if it was an hour, we don't really care. So we could tune things, and we could take decisions to make them configurable. However, configurable in a way that was not using the config service that we were going to DDoS when we got our configuration. I should call out. And you must implement and act on the recommendations. Otherwise, what was the point? You've done all that hard work. You've had a crisis. You've come through it as a team. You've pulled together. You've solved the problem. You've written the report. You've taken the lessons, and you have learned nothing. And it'll just happen again. Yeah? So somebody has to own that incident report. They have to take those learnings and they have to implement. And that means you have to put times on them. We will do this by a month from now. And somebody has to own it and check. But the one thing I do want to say is, throughout all of this, throughout the whole incident, the most important thing, the single most important thing you have to remember is it's nobody's fault, right? When the world is on fire, you cannot blame people. You're all in the canoe, it's got a hole in it, stop trying to hit each other with the paddles and bail the water out. And continue that after the end of the incident. It's still nobody's fault. The app config team didn't mean to change the response. You know, there was no malice in that. The root cause of the incident, with no, you know, completely impassionately, was the app services team deployed an update which changed the behavior of their service. Don't make it personal. Don't bring any blame into it. Because if you do, the next time there's an incident, people will shy away and they will hide and they won't engage, and that doesn't help you if you're trying to pull together as a team. And on that, hopefully, salient point, I will say I hope that was useful and interesting to you. If you have any questions, I'm around. If I'm just standing between you and coffee, well, thank you very much. Does anybody have any questions? I have a microphone. I'm not afraid to hand it out. So if you do want to go, by the way, I'm not going to be upset. Feel free to go find coffee. Oh, sorry, I've left the microphone away. Is this on? Right, sorry, I'll start there, and then you've got one as well, haven't you?
Thank you, Rik. Great talk, showcasing the collaboration. Sometimes we forget about that, but so I wanted to ask you about the epilogue. I mean, epilogue. Which is measure do you take after solving this? I mean, as you said, there was no monitoring about the KeyVault because no one expects so many requests and so on. Did you?
So we took actions, and off the back of this, I created a whole bunch of Azure alerts that were looking at service metrics and that would alert based on, so in Azure you can do heuristic alerts, so you can say if it goes above the average flag, and we also set very specific levels, so we could say, okay, if the metric that says the KeyVault utilization goes above 65% or whatever we set it to, pages. And the reason that we did both of those is the heuristic ones are great and can give you early warning, but if you're under high load already, the average can be, you know, quite a bit higher. And specific values are good. You can only do specific values, though, if you've got a good idea what your normal load is, which brings us back to having telemetry. So as a result of that incident, we've got probably nearly 100 alerts now. And as we add new services into the mix, we'll run them for a little while. We'll see how they behave, and we'll add alerts in. So we've got like service bus queue length. We've got app service memory use, KeyVault's utilization, app config utilization, all of that kind of stuff. And then you can start pulling those into dashboards and graphs and that kind of thing.
Thank you. Yeah, very good.
Okay.
Good measure.
And sorry, was it one of you? Sorry.
Hello. It was interesting that I had a very similar issue with KeyVault also, but the path for the root cause was shorter. What we did, we look at the logs of the KeyVault, the diagnostic logs, and we found we grouped by the IPs of the callers, and we found who was the caller that was doing DDoS through the IPs.
Yeah. Because
you have there the source IP from the caller that is hitting the API of the KeyVault, and we grouped by the IPs and we found it was a very short path.
That's really helpful, isn't it? If you've just got one bad actor that's DDoSing KeyVault.
Yeah.
But for us, every single service was doing multiple, it, so that didn't really help us.
You have multiple sources, but maybe through the IPs you could see that the outbound was coming from the app configuration.
So that's kind of interesting. So app config doesn't call KeyVault. Your code, we call KeyVault based on what app config tells us.
It's the SDK?
Yeah.
And it's not doing
app config
exponential retry.
App config doesn't proxy KeyVault. App config returns the KeyVault URI back
it's
to your
code that got the value from the. In that case, you would see that it was the code. Okay, the app configuration was giving you the returning error code incorrect. So the
So
code on web app was calling
config
the
swallowed the
KeyVault.
exception as well and didn't tell us that it was getting.
And this probably the SDK was not probably doing the exponential retry, right? Because
And the moral is we fed all of that back to the SDK
Yeah.
team. Right now, I haven't looked to see if they implemented any fixes, but I'd be surprised if they
in
haven't.
my case, the issue was the same. We saw that the outbound we are not using private connectivity, so the outbounds, the IPs we saw were the outbounds of the web apps
Yeah.
on that zone.
Yeah.
Then we went to see the code, and the issue was the code. The
Yeah.
code had a bug. It was calling.
Yeah, and we could see similar things. You remember those graphs with all the
Yeah.
different colored blocks? So we could see that, but that still didn't give us, it didn't get us to the root cause because, yeah, we could see that our code wasn't right, but when we'd taken steps to fix our code, we were still getting the issue because the
Yes.
SDK.
So yes, it was a tricky one.
Yeah.
Thank you.
It's okay. And then gentleman behind you.
Simple question. Did you get a refund for this KeyVault?
Yes, that's a very good point that I should have mentioned. So, if Microsoft breach an SLA, they will give you money back. And you should go and talk to your account manager and go, hey, you just cost us £1,000 because of this. And you can point to the fact that it was a clear breach of the SLA for app config. So yes, they gave us some money back, which is a very good point. Thank you. Anyone else?
Do you know how if any other customers of Microsoft were impacted by this?
I don't, and that's a really interesting question. So I have asked around, and either people don't want to admit it to me or didn't notice. Now, to be fair, we have a very large number of KeyVault secrets. So if you're mostly using app config, you wouldn't notice. You're just making more calls. It was only because we were DDoSing KeyVault that was then impacting everything else that we spotted it. So it might be that we were just really gosh darned unlucky that my devs are all really paranoid and everything goes in as a secret. But yeah, it was a good question.
Did Microsoft change the status page of the app configuration service?
That's also a good question. No, so Microsoft did not change the status page. To be fair, I think that's because by the time they realized it, they rolled the fix back so quickly. Once they'd done their investigation, they didn't
But
update
it
it.
generally also shows there the previous incident. It should be there.
Yes. Let's not talk about that one, shall we?
Yes, it's not the best place.
Cool. Any more? Thank you. All right. Well, again, thank you very much for your time. I'm glad you enjoyed it.